Hey, I'm Salvador Deewa. I'm here to talk about VATs.
So let's start with a presentation. What VATs are? Okay, as you're using base colors or normals as any other texture map, you're using this one because it's a texture as well to replicate the movement that it should have as it has bones. So you use the pixel from this texture to move vertices with them. I will explain this better in the presentation. So the first image we have in this presentation is an animation texture. Okay, that's how it looks like. It can be kind of crazy that it can work with something, but as any other texture map, you can use this to move vertices instead of just paint them. World position offset. As you can see, you are moving vertices real time, and this is what the WPO does. So you are just selecting some vertices, giving them some coordinates to move around, and they are just executing that movement over and over and again in runtime. And UVs. You usually apply them to 3D textures or to paint some 3D models, but in this case, with the correct usage that I will explain later, it's key to use them to run the vertex animation texture while using the world position offset. How WPO works? Here we have Yuki that will be used to take some examples. And as you can see, I'm just changing between some values in the color, and we are transforming that color into a coordinate. If we are writing 100 in the B side, we are just moving it in Z axis, and Yuki, as all the vertices are being affected by this WPO, is moving to the direction that is being selected. What a texture is? A texture basically is a 2D matrix of pixels. That pixel owns a color, and as we saw in the WPO example, each of the colors refers to a 3D vector. With that 3D vector, you can use them to recreate the animation with each frame. How? The first example we have is a 2x2 matrix. So how does this move the 3D model? Well, depending of the number of vertices, the row of the texture is based on how much vertices it has. And the columns are based on how long the animation is. So we can say that in the first image, we have a 3D model of 2 vertices with animation of 2 frames. And at the right, we have a real vertex animation texture that we are using actually in the game. So all the black spots are probably because the numbers are below 0, so they are moving in a negative coordinates. By the way, as you can see, the first line of the texture is completely black. That's because it's the idle, so you don't have any movement in the idle. This is a good example because we have a complex model with a lot of vertices with an animation that takes a lot of frames to reproduce. Recreation of movement. At the left, we have our 3D model, already with the bats baked, being moved by WPO. Okay, everything is fine. It's an static mesh. It doesn't have any bone or any morpher or anything like that. At the right, that white line we have there, that's are the UVs. So we have the index 0 at the left and aligned with each of the pixels of the texture the next vertices till the length of the 3D model's vertices maximum amount. So what it's doing is that white line is just moving from up to down over and over and over again, aligned with the pixels of the texture and just recreating the movement. So yeah, that's how it works. Let's talk about some extra functions. As we are using a shader and we have a texture, we can modify or add some features to this shader and modify the texture as we want. Here, for example, we have an exaggeration value that modify the animation with a lot of impact in the file. So this is the end of the presentation. So let's make a bat ourselves. Okay, so let's create our Vertex Animation Texture. The first thing we have to do is to import the 3D model with the animation, okay? So here we have this teapot with this animation, right? Uh, Why am I using Max? This is because Epic already did a tool for this kind of technique, and it's placed in here, like the engine, in my case 5.3, engine extras 3ds Max scripts, and this tool here, Vertex Animation Tools .ms .max script. So yeah, we just have to drop this here inside the viewport, and we have this window. So I will explain the most important parts of it. Anime start is where the animation starts to bake. Anime end, the same at the end. So the animation ends with the frame 46. Let's write it. And frame skip, it will just bake the animation each skip that you write there. For example, if you write a 3, you will bake one of the pixel rows each 3 frames of the animation. And texture coordinate. This is just to place the UVs you're going to be using for the vertex animation. And in this case, as I'm just using a teapot that only has a UV set, I will leave it at 2. If I have, I don't know, a complex 3D model with a lot of texture because it's really big or whatever, okay, I'm just using the texture coordinate to one more of the numbers of texture it has. If I'm using 3 sets, I will place it in the texture coordinate 4. But yeah, as I'm just using one, I'm gonna place it in the 2. All right, so the next step is just to go to customize, unit setup, and place everything to centimeters. If not in centimeters, it's not going to work. All right, let's bake. Preset animated meshes, and there we go. We just have to replace or just move it there, save it there with the name you want. Let's say teapot, and that's all. That's how you make the bake. The name we have here in the 3D model is the name of the asset you made in the bake, where you have the UVs for the animation texture, and then morph export just to identify if it's a vertex animation model or not. Okay, so in Unreal, now we have all the resources that we need to make the animation textures work. What we're going to do is to import it. Yeah, why not? So let's grab here the teapot. I want the material, so I don't have to create it. And the textures here. All right. So for the static mesh, we have to go inside and search for UVs. And the toggle use full precision UVs, make it true, and apply the changes. Then we have to go to the textures and tweak two variables. So the compress settings must be always compressed as they are compressed. And the other thing we have to do is in filter choose nearest. Why? Because right now Unreal is managing the textures with a gradient between pixels, and we don't want that because we want our UVs to fit perfectly in the pixel. So to do that, in filter we go to nearest, and in nearest we have some kind of pixel art texture that respect 100% the pixel color. So that's perfect for our UVs. The same process with the normal. I will explain this later. We have the gradients. So well, first of all, as they are compressed, and in filter nearest. By the way, be sure that it's not sRGB because it will be bad as well. All right. So let's create the material. M teapot, and we were going to choose the teapot for the visualizer. All right. So Epic also, see if we write Vertex Animation, they prepare a material function for this purpose. So let's grab the texture, let's drop it inside, and we have to make them convert to texture object, is the requirements for the function to work, as we can see here. So why two textures? The first one is the normal, because when you're moving WPO, you are not really changing anything about lights or shadows inside the 3D model, because the light is always casting to the model in the WPO 0. So any change is not affect to the lighting, and that's why we change the normals. So if we change the normals, they will be uh, merged with the main normals of the 3D model, and they will start to create that shadows and that lights as if the 3D model had the correct lighting in the scene. So plug it here in normal, and the second texture is just the one that is managing all the movement stuff. All right, so let's plug it inside the world position offset. We have the animation working. Roll is low, so we'll create the time node, and with the time real scale, we have the animation real time. If we want the animation to have different velocities, we multiply it by a scalar number called velocity, and it will change the velocity of our asset. Perfect. So if we save this, we place the teapot inside Unreal Engine, and we place the texture. There we go. We have an animation texture. So yeah, I hope you understand everything about this video. If you have any question, feel free to ask to me. And yeah, thank you so much for watching me, and see you in the next video. Bye bye.